There she goes again. There she goes preaching about sound waves and frequency and wavelength and blah, 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 blah. Wait, that's better. And as she talks, the guy behind me is playing Angry Birds under his desk, and the girl in front of me is trying to take a selfie for Snapchat without the teacher noticing, which is actually quite impressive. And because I lack a smartphone, I have to resort to prehistoric methods of keeping me entertained. Doodling. I mean, why pay attention? In 5 years, we will all be famous songwriters and super rich, right? The question I always hear in school is, when will I use this in my life? But as they ignore the teacher, they fail to realize the importance of physics. The only physics these people understand is the physics of launching birds at green pigs. Which they probably don't realize that it's a projectile motion relates to physics, but there's so much more to physics than gravity, and Angry Birds. Yes, music, like the Beatles or Jimmy Buffett or One Direction or Miley Cyrus. Famous people. Okay, maybe not Miley. Famous, not notorious. But music is physics. There are so many connections between the blah 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 that she's talking about to the music we hear on the radio. So before you become a famous musician, you should understand the relationships between music and physics. She was just talking about frequency. Frequency is the measure of vibrations per second. And you should already know that vibrations create sound. From guitars to vocal cords, all vibrations. And notes? Yeah, you know notes. A, B, C, D, E, F, G are letters that are assigned to exact frequencies. She just said that the note C, middle C, or the C in the fourth octave has a wavelength of 1.301. So if we do a math calculation, frequency equals velocity over the wavelength, the velocity being the speed of sound divided by the wavelength, which is represented by the lambda sign, which is the unit for wavelength, we get 261.626 as our frequency, which is the frequency for middle C, which is here. I've played piano enough that I should know what it sounds like. There it is. Even in my mind I can hear notes. Sweet! So here is middle C. Given all these other frequencies, we can figure out the rest of the C major scale. And actually, we can figure out the relationship between the notes and the correspondent to the bass note C. Now, the relationship between the C in the fourth octave and the C in the fifth octave is 1/2. This is the reason we don't have a note or scale of H. It's because when frequencies double, they sound similar due to the wave structure. See? They line up. When the notes repeat, it's called an octave. It's the 8th note, hence octave. But I bet you look at a piano and wonder, what about all those black keys, and what about when people say A flat or F sharp, how those sharps and flats are related? Well, someone figured out that when you play a major scale that's not C, it doesn't sound the same. Here, we use E major as an example. And it doesn't sound as good. Going back to our relationship fractions to the notes in the C major scale, they should work for an E major scale. But they don't. So musicians had to use the relationship fractions to find new notes, which are in between the other notes, giving you the sharps and the flats and the black keys on the piano. And with these relationship fractions, you can create chords and songs with every note or key. So pause Angry Birds and pay attention. This might make you famous.